Another counting up. Okay, cool. Hey Hacksters, it is Monday, thus it is MCU Monday, and I have a returned item actually from one of our out shipments. So as you may know, we do contests all the time. You go to Hackster.io/contests and you can submit your ideas to win free hardware, to build cool projects, to win more cool stuff. So there's like multiple ways you can win. Usually there's like a beginning point where you submit your idea and then like a certain amount of hardware kits, for example this one, are shipped out to the best ideas, and then everyone gets a chance to build it, whether they buy the hardware or win it in the first round or whatever. So it's a pretty cool deal, and sometimes though, as with all shipping issues, sometimes we have problems. And so we get things back, like this. And so I've never seen this before, except for like half an hour ago when I started researching it. And I think it'd be interesting to look at. It turns out it's from a little bit of a while ago. So this is labeled the Pico-Pi i.MX 6UL, which is apparently one of the older versions of this board. If you look up wandboard.org and similar things, you will find that it's associated, oh yeah, it's definitely designed for building with Android things, as implied on this label here. But the more recent versions seem to all include this i.MX 7 version, which I believe is a later iteration of the same board. So if you go to the Technexion page, you get this Android Things starter kit. You can still buy it for $200, and there's 66 of them left, but this is the i.MX 7 version, so it is slightly different. What OneBoard says about this board is that the reason behind the development was that many of the development boards we see today are fun to play with, but there is no flexibility in place to design a product beyond the initial stages. So what they've done about this, is as they say, is to use a system-on-module approach. What does this mean? This means that basically the actual thing that does the thinking, the brain of this board, is about yay big. And then it's mounted onto a board that's more the size of a Raspberry Pi and has the usual Raspberry Pi breakouts, and also breakouts for like touchscreens and, well, I guess the Pi kind of has that. But also a mikroElektronika click breakout, which is interesting for prototyping because if you're not familiar with the click boards, they're sort of similar to Seed's Grove modules, where there's a ton of them and they make it really easy to connect to all kinds of different inputs and outputs, sensors and actuators to your electronics without having to, it was basically pre-made connectors, and you don't have to dig out all the jumper wires, and you don't have to like figure out how to program the thing because they've probably got a bunch of examples and stuff. Back to the descriptions. Again, there's these more intense i.MX 6 units from Wandboard, and they also have the i.MX 7 ones, including this starter kit, which comes with a bunch of cool stuff. Actually, seriously, let's look at this. It's got this cardboard, like, holder module that will hold the screen and the computer and the antennas, and this Pimeroni rainbow hat, which has, like, 7-segment LED display and programmable RGB LEDs and stuff like that. All that stuff. This, what I have here appears to be just the board. But yeah, so these are all based on the i.MX 7, and then there's even the i.MX 8M and Lite and Pro and Dev and stuff. Super cool. And extreme! I'm always sad when my kits aren't extreme enough. Yeah, so I found the datasheet for this thing, and they have a pretty good overview, so I kind of know what we're in for once we open this up, and I'm going to do that right now. Yeah. So, I have taken the liberty of already opening this up, but I have not gone beyond this stage. So what we have here is a couple of antennas. We have a small one and a big one. Actually, no, wait, this is just the thing that connects it to the board. Okay, yeah. This is sort of like plumbing fittings where you go from one to the other with another type of connector. Anyway, so yeah, this connects to the board, this connects to that antenna, like so. Then we have this USB-A to C cable. So the C side connects to the board and gives it power. It also has, as we will see, a micro USB debug port. This is the point of no return! I mean, I could just stuff it back in the bag. It's definitely a point of return, but whatever. Okay, so, yeah, looks like a Pi, but kind of on steroids. I don't know if that's okay to say. But yeah, we've got the camera output here. We've got the, what is this one for? Let's take a look. That one is the RGB TTL display interface, so that's for touchscreen. There's also an I2C breakout for a touch panel, which is interesting. And there's a display selection switch. Pulling back to the device itself, let's refocus here so we can get up close and personal. Yeah, that's the stuff. So you have your usual audio breakout jack. I think this is in the usual place for a Pi because pretty much everything else is. You've got the Ethernet over here, one USB, one lonely USB-A port, but when it lacks in more USB ports, it makes up for it in other stuff. So you've got the standard 40-pin Raspberry USB out. You've got the standard positions for the mounting holes that you can use with standoffs. You've got the USB-C over here for the power. This itself is the SOM, the system on module, with the NXP chip over here. It's still labeled as a Freescale chip, but yeah. And then I want to show you how these mikroElektronika click things go in, because I think it's pretty cool. I haven't actually opened this one up. It's a relay board, but it's got some cool packaging too, right? Pull out. Wait, what happens when I pull it out? Oh, I pulled this out. Haha. Cool. So this is a little relay guy with documentation all over it and this beautiful origami design. And that would just go over here, or maybe over that way, I'm not sure. Let's see, how are they labeled? JP1 and JP2? Are these labeled 1 and 2? IDK. I'm not going to assume, so we can look up the documentation later and see which way this is supposed to go on. But yeah, I'm going to assume it would go that way, but I don't want to mess it up. So here we have the actual system on module itself, and that includes a power management IC, which is hidden under this sticker, I think, and the flash eMMC chip, and this guy handles all the Wi-Fi and Bluetooth. That's 802.11 BG/N. And then here is this is an ARM Cortex M7 chip. It's interesting because I would have assumed that the i.MX 6 UL would have a Cortex 6 and the i.MX 7 would have a Cortex 7, but that is not the case. They are both. Let me just show you what I'm looking at. Up here it talks about the SOM itself. You've got the memory chip here. You've got, the eMMC is actually on the bottom, that's the 4 gig one. And then they've got this 512 meg DDR3L memory on the top, on the actual SOM itself. Although that might be on the bottom of the SOM, not sure. It has this little connector that's similar to the Edison connector. So we might be able to just pop that off once we remove those little standoffs. But yeah, then there's the Broadcom chip that handles the wireless, and then you've got the i.MX 6 Ultralight, which is what the UL stands for, ARM Cortex-A7. So I pulled that up, and it is a high-performance, ultra-efficient processor family featuring an advanced implementation of a single ARM Cortex-A7 core. So it's a single core, but it can go up to 696 megahertz, and they sort of suggest it for connecting to peripherals such as WLAN, Bluetooth, GPS displays, and camera sensors. But they don't really have a lot of... Do you have suggestions for what to build with this? Not really. Application notes, maybe. But they've got this little video about it and everything, so you can check that out. That's on the NXP site, and I've linked that in the description to this video, I think. Then the rest of the connectors on the board, like I mentioned, this is kind of a breakout for the SOM itself, include your Raspberry expansion headers. Then these guys over here are boot select pins, so presumably you can have different boot modes. You've got the debug serial interface over here, that is that micro USB. You've got the regular USB-A, mikroElektronika connectors, Ethernet. Oh, they call it a microbus expansion header. Then we have the audio connector. Anything we didn't cover. I think we've got the reset button, which I didn't talk about yet. Reset button! Glorious features! It feels pretty good for a reset button. Okay, let's see if I can pop this off, actually. We already looked at the bottom, so... time to potentially break things. Okay, I'm off of there. Is it sacrilege to use... ooh, pardon me. Is it sacrilege to use Intel pliers on an ARM chip board? I think not. Everyone can play together. In case you're wondering what I'm talking about. Cool. Can be nice and gentle here. The nice thing about these standoff connectors, oh yeah, there's our antenna connector. About these standoff connectors is that they kind of give us a guide so that I can't pop this off at too much of an angle and destroy everything. Come on. I want to see what's under there. It's got 3 of those, like, how many pins? Hyros high-speed 70-pin board-to-board connectors. It has 3 of those, so I'm not really surprised that I'm having having to apply a little bit of force to get this off. Let's see if I can safely sort of brace this on the plastic over here. Oh. I'm kind of, without applying force to anything. Close enough. There we go. There's that other memory chip. Kingston. Excellent. What did they call it? They just called it the i.MX 4 gigabytes of storage. 4 gigabytes. So pretty. So small. Right, so those are your little high-rose connectors. And the back of the entire Pico i.MX UL i.MX system on module. Delightful. Now, if I ever want to use this again, which I don't really have to because it came back after a contest, but I want to be nice. I would like to try it out at some point. Just sort of squishing those connectors back together again. That feels about solid. It looks even. So I'm going to call that connected and stick these little guys back on. I'm going to see if we have any questions from the crowd before I wrap this up. What do people say? Didn't Google kill support for Android things? That's also true. So as I said, this is kind of a vintage board at this point. It's a little out of date. And if you want one for curiosity's sake, you can go buy one for $200, but I probably wouldn't. Seeing as how that has all gone down. But it looks like one board is actually continuing to make things in this family, in case you want to check it out for other purposes. It's so hard to remember. I also thought that Android things had been ended, but it seems so recent that it was still doing stuff. Someone says, hello from France. Do you like the Raspberry Pi Zero? What do you think about it? I think it's awesome. So there's the Zero and the Zero W, which is the wireless version with Wi-Fi and Bluetooth. And the Zero is, I think, $5, and I think the W is $10. And they are slow compared to a computer or even a regular Raspberry Pi. But they definitely get the job done. Like Archimedes, my robot owl, which is in a box over there, his brain runs on a Raspberry Pi Zero W, actually, and it does the job. What he's doing is running an AI neural net model to try and figure out if people are happy or sad. You can also do object recognition with models both stored on the device, no need for Wi-Fi or Bluetooth, and it has a pretty fast response, which is really impressive. So I think they're fantastic, especially at the cost point. So the whole point of the Pi in the beginning was to be an entry point for people wanting to learn software, particularly as like university students. And it has, I don't know that it actually is used in that way in most places, given that I feel like, granted, my experience stems mostly from Europe, China, and the US, but what I see it mostly being used as is an adjunct board to either have a spare server to play around on and not worrying about borking your main computer, or, for example, something to actually get started with hardware as a software person. And so it follows very well in that tradition, and I think that its smaller size is definitely very nice as well. Someone says, nice hair color! Yay! Oh, cool, yeah, you didn't know about the W model. It's awesome! Go check it out. I think it's just $10. It's amazing. And any other questions? I think that's about it. Thank y'all for joining. Have an awesome rest of your Monday, and we'll see you tomorrow for something. We'll find out. We might have an interview for Hackster Cafe, but I'll have to check my calendar. All right, catch you around. Cheers.